Oke, jadi kita langsung aja, kita akan melakukan demonstrasi bagaimana KNN itu dijalankan di Python ya, pakai scikit-learn. Kita pakainya Google Colab. Di sini KNN neighbor-nya kita membutuhkan import beberapa library ya. Yang pertama sebenarnya ini nggak perlu ya, karena kita nggak akan ngeplot, ini nggak usah. Yang perlu Anda perhatikan adalah yang ini, metriknya dulu. Seharusnya yang kita import pertama kali adalah algoritma ya. Ini saya taruh di atas. We put it here. Right. We import the first one is the scalar neighbors. Import k nearest classifier. Jangan salah ya. KNN di dalam scikit-learn itu namanya adalah k neighbors classifier. There's also another one. KNN. You can find out scalar like this one. Atau neighbors. No, there are a lot of variants of nearest neighbor algorithms. You can choose either this one, but the most common one to use is k-neighbors classifier. If we need to classify in the supervised machine learning, we have classification. If you only have 2 labels, 3 labels, some labels, then you have to use this classifier. If you have multiple numbers in the labels or various numbers in the labels, then you can use k-neighbors regressor. This is a different approach in k-nearest neighbor, but we are focusing on this one. Nah, oke ya. And then the new thing atau sesuatu yang baru yang kita tambahkan di sini adalah metric. We need to measure every time we build a machine learning model, prediction model, classification model, we have to measure the performance of the algorithm. We can use this one, precision recall F-score support, and then don't forget confusion matrix, and then classification report, and or accuracy score. But the most common one, we only need these 3. Accuracy, precision recall, F-score. That's it. And then we also need to import the model selection here, and then we only use this stratified kfold and the train test split for the holdout cross validation. Don't forget the test case is the breast cancer test case. This is binary. An example of binary is binary label dataset. Nah, maksudnya adalah di dalam breast cancer itu cuma ada 2 label kanker atau kanker ganas atau jinak ya. Di dalam inside this dataset there are only 2 labels, the malignant cancer or the malignant and yang jinak ya. Malignant tuh yang yang ganas ya. And we also need to import numpy as np. And then we need to load the dataset into x and y factor. Yes. This x means a vector of attributes, and this y means the vector of classes. Oke ya, kita jalankan ini. Oke. No error, and then we go on to the first demonstration using holdout cross validation. Holdout cross validation. You see here, kalau di holdout cross validation, we split the dataset into 2 parts. The train and the test. That means we have to split the attribute between the x, the attribute for train, the attribute vector, the train attributes and then the test attributes. And we also need to separate the labels, the train labels and the test labels. The train test split XY and the test size is 0.8. That means we split the dataset as 80% dataset goes to training set, while the remaining 20% goes to the test set. Yeah, and then this random state is for repeating, because when we do this stuff, it's a random sample basically. If we are using random state 42, that means if we repeat the process over and over again, it will produce the same training test split. Ya, jadi menggunakan random state ini memastikan bahwa setiap kali kita lakukan sampling untuk pemisahan ini ya, datasetnya menjadi train sama test, itu akan selalu menghasilkan kelompok training sama kelompok testnya itu sama terus. If we don't use this, that means it will be randomized. Yeah. So make sure that you set this random state 42 or any number you want. This 42 is magic number. And then we can set we can initialize a variable called KNN as k neighbors classifier with the hyperparameter set as follow, like this one. Jadi kita menginisialisasi model dengan hyperparameternya itu adalah n neighbors sama dengan 3. Kita lihat ya, we go on to this library for k neighbors classifier. It consists of these parameters. N neighbors itu maksudnya jumlahnya sampel yang terdekat ya. Jumlah sampel terdekatnya berapa? If we do not set this n neighbors, that means we are using k equals to 5. And then we can use the other parameter is the weight. Weight means apakah kita menggunakan jarak atau uniform. Ya. Uniform means uniform weight. Distance, weight points by the inverse of the distance atau yang lain. Lalu ada algoritma leaf size, P metric ya. The default for this is the distance metric, but if we do not set the distance metric, it will use Minkowski. Ya, kita bisa lihat ya distance metric pilihannya apa. We need to set out ini Euclidean. Ada pilihan lain ya. Nah, banyak. You can choose the distance metric for this KNN. Either the default is Minkowski if you don't set. If you don't set the distance metric, it will use Minkowski. If we want another distance metric, you can set out Euclidean, Manhattan, Chebyshev, S Euclidean, Mahalanobis, etc. Ya, bisa kita ganti. So, karena ini adalah contoh, berarti we need to set the metric. What we call that? Metric. Euclidean. Because we need to use Euclidean distance, you need to call the Euclidean in parentheses. This is an initialization of the KNN. And the following line is to train. Ya, ini melakukan training the model. We train the model like this one. Once it is trained, KNN fit X-train. Nah, trainnya menggunakan apa? Menggunakan X-train sama Y-train. Jadi implementasi di dalam the actual implementation when we are using the code, we have to actually train the KNN. Although, as I said, that KNN doesn't need, it's like on-the-go prediction. Ya, model yang bisa prediksi on the go tanpa training ya. Tapi sebenarnya di dalam supervised learning yang menggunakan Python ya tetap kita lakukan fit ya, kita harus training. Once we have trained KNN, then we can produce the prediction for the new samples. What are the new samples? Is the X-test. X-test means we use the input values from the X-test to predict the output values. The output values, we store the output values into a vector called y prediction. And this is the prediction class, and we already have the true value from the y test. Ini ya. Nah, ini udah dapat kan? You can simpan confusion matrixnya bagaimana, tampilkan confusion matrixnya. Oh ya, target names-nya adalah malignant and benign. Benign itu jinak, malignant itu ganas. Kita coba. Wah, ada error. Ini karena kita belum panggil yang ini tadi. Because we commented the matplotlib, so we need to use that again to plot the output. This is the output of our KNN performance. You can see the accuracy is 0.9 overall. Ya, akurasinya ya, makro. Kita bisa lihat bahwa presisinya untuk yang malignant. Jadi sebenarnya presisi recall F-score semua metrik itu adalah ngelihat dari sisi setiap kelasnya untuk kinerjanya. As you can see here, the precision for malignant labels are 0.8 recall, etc. Ini yang bisa kita lihat ya. This performance shown like so is indicates that the KNN works very well. Above a 0.80, it's a very good prediction model. Ya, ini cukup bagus ya. But you have to remember that we are using holdout cross validation. Holdout means that it is only good when there are a potential of overfitting potential if we are using holdout. That's why I really recommend you to use the kfold cross validation. Nah, kalau pakai kfold cross validasi berarti we have to split data set into some partitions. Yeah, we need, for example, we set out the kfold as 10 folds, and that's why we can create 10 models of KNN. 3 classifier KNN ya. 10 classifier KNN. Kita set ya di sini tadi KNN-nya di train nggak nih? Oh, KNN-nya belum di train. Oh, we use the same KNN ya. Previously initialized here. Ini udah diinisialisasi ya KNN-nya. Nah, jadi kita gunakan di sini, tinggal fit aja. Sebenarnya KNN-nya harus di set di sini. Basically, we need to copy this and put it here. Right? Untuk memastikan aja. Okay, so inside we have this HKF as stratified kfold with K as number 10. That means that there will be 10 partitions in the dataset. And then ini kita pakai for train index and test index, maksudnya in SKF split. Once we split the dataset, ini kan dataset ya. Once we split the dataset, it will create a group of train and test index for the dataset. Jadi caranya kita ngambil training set sama test setnya adalah menggunakan X dalam kotak kurung itu indeksnya aja. Test index, train index, test index gitu ya. And we can fit the KNN using the X train sama Y train ya. Kita latih dulu. Lalu kita prediksi sama dengan cara yang hold out tadi, we predict and then we measure the confusion matrix and then we show how well each model produce using this kfold cross validation. Let's find out. Nah, ini hasilnya. Sorry. Nah, this is the first fold. In the first fold, we have this performance. Kalau kita lihat akurasinya 0,93 ya, overall. Precisionnya juga bagus. The next fold juga tetap bagus. Fold ketiga bagus juga. Fold keempat bagus juga. Oh, lumayan menurun ya. It goes down. You can see this is the false positive. This is false positive. More false positive. Jadinya makanya recallnya rendah. Lalu kesini lagi yang masih bagus. Fold ke-6 lumayan. Fold ke-7 not bad. The 8 fold, 9 fold, the last fold. Nah, ini bagus semua ya. Jadi caranya kalau if you use k-fold cross validation, then you have to measure the average precision from each fold. You have to store the average precision within each fold, and then you measure the average of precision of overall models. Then you can find out how well the overall classification model you have created. Gitu ya. Nah, yang kita lakukan di sini itu kita pakai k-fold cross validation. Seperti ini. Tapi di eksperimen yang sebenarnya, karena KNN ini berbeda dengan berbeda dengan naive Bayes ya. On KNN using k-fold cross validation. Nah, kalau KNN berarti kita bisa main-main sama hyperparameternya. Hyperparameternya kan banyak. We have a lot of hyperparameters. You can either choose which one you want to experiment with, but I prefer we are going to experiment with n neighbors. In the supervised, in the KNN, we only play with or experimenting with the neighbors only. While other parameters are in using the default, except this one, except this metric, we use the Euclidean distance. What we need to do there, kalau Anda lihat, if you see this part here, until here, this is basically similar with the k-fold. Up to here, it's similar with the k-fold cross-validation. Yeah, similar with k-fold, yeah, from here to here. But because we are experimenting with the n-neighbor hyperparameter, then we have to encapsulate this for loop here with another for loop where these the parent for loop have values of these neighbors from 2 to 10. Ya, dari nilai dari 2 sampai 2 to ini 2 to 11. Range 2 to 11 means that it will create an array of values between 2 until 10. This 11 is exclusive. It's not excluded from this parameter here. Ya, jadi di sini ada parameter, ada for loop tambahan di mana ini for loop ini adalah untuk mengubah-ubah nilainya dari neighbornya. Nah, di dalamnya for loop ini nanti kita bangun nearest neighbor KNN-nya, ya. Kita set metric Euclidean. Nah, oke ya. Then don't forget we need to store, because we have experiments, we need to store every value, every performance from the KNN we have trained and test. So we need to create an accuracy array, and then precision array, recall array, and F-score array. Nanti kita isi nih setiap arraynya ya. And then in the next for loop here, in the for loop inside this experiment for loop, we train the KNN and we predict the values of the X test, of the test set. Then we can store the accuracy using accuracy append lalu accuracy score dari y test, and then y prediction. And we also need to get the value from the precision recall f score from the same parameters y test, from the comparison between the true value and the predicted value. And then we need to append those precision recall and f score to the array, the relevant array. Nah, setelah ini beres, once we have store everything, every matrix, performance matrix in the array provided here, then we can output the performance by using this numpy min and then the array and axis 0. The axis 0 means it's the along the axis 0, along the a row of data. Ya, ini pakai axis 0, jangan axis 1. Ini kan this array is a one dimensional array, it only has one axis. If you have two dimensional array, then you have two axis. Then you can choose either axis 1, axis 2. Tapi di sini karena cuma satu array satu dimensi, berarti kita pakai axis yang pertama aja. Ya, kita lakukan semuanya, kita hitung minnya itu maksudnya rata-ratanya ya, mean dari semuanya ini. Udah, hasilnya begitu. Setiap KNN, setiap nilai K pada KNN-nya itu akan dimunculkan hasilnya. Nah, kita coba ya. Nah, ternyata nggak lama juga ya, cepat aja. Nah, the first KNN with K equals 2. It has this matrix. K equals 3. Okay. It performs better than K equals 2. K equals 4. Not bad. Relatively lower than the K equals 3. This one is a bit higher, more the highest one. Lalu ini yang terbaik. Ini juga lumayan. Ini meningkat ya. Nah, K equals 8. K equals 9. K equals 10. Okay. The 8 experiments we have produced here, we can jadi if we have this kind of data, numeric data like this between each experiment we have performed, it's not easy to find out which one's better. That's why you need to plot these values into a graph. For example, you can use Microsoft Excel or use Matplotlib to show the changes of accuracy between various K and then precision between various K recall. Jadi misalnya kita punya Excel ya. Jadi ini kalau cara manual, then you need to use Microsoft Excel. You put out the values 0.90 ini ya, terus ini ambil lagi ini, terus ini ya, saya wait. So sorry. From this data we have moved from our experiment in Python and put it in Microsoft Excel. We can create a line graph and showing how well every experiment we have done to KNN using various K in the matter of accuracy. Yeah. You can also measure everything. You can also plot the other performance metric like precision recall with the same procedures I've just shown you like previously in accuracy. You just put the precision here, and then recall, and then f-score, and then put the values and then plot this in the same graph. That's no problem, and you can find out which one's best from the overall performance matrices gitu ya. Jadi dari sini setelah kita tuliskan presisinya, kita tulis di sini ya. Presisi tulis di sini 0,95. Lalu recall-nya berapa? 0,91. F score-nya 0,91. F score-nya 0,93. Nah, dan seterusnya. Maka nanti kita bisa melihat hasil akhirnya. Hasil akhir dari once you have write down all the remaining performance matrices, then you need to plot the output into the graphs here. Saya pause. Once we have put all the values in our table here, we can plot the output as follow, like this one. And you can see which one has the best performance from overall matrix. Jadi nggak cuma dilihat dari akurasi yang biru, the blue is the accuracy, the orange line graph is the precision, and the gray graph is for recall, and the yellow one for F-score. From these experiments, we can see an overall view observation to the KNN, the experiments of KNN using various K, ya, various K. Ternyata yang terbaik yang mana? Di sini kan? This one is the best. This part here. I can assume this is the best. Best KNN. K sama dengan K equals to 9. Ya, ketika kita tarik terus. Nah, gitu caranya. Once we already have this kind of graph and we can find out the best KNN with the K value, it's shown here. Then we can analyze. We can argue. We can write down arguments that our KNN produce is very good. We can set the K equals 9 for the KNN to produce the more optimized. Ini yang maksudnya adalah this plot shows if we set the KNN with K equals 9, we can produce optimized KNN, optimum KNN. Ya, optimum or best KNN or best KNN. Jadi optimumnya adalah ketika K sama dengan 9. But you have to remember that if we plot our value, if we plot our performance matrix in this graph, you have to always start this y-axis from 0. Karena kalau mulainya dari gini kan kelihatannya, if we start our y-axis from a number, it's not from 0, it's like a zoom of that y-axis. We need sometimes, but it's the best practice. We have to start from 0. Jadi kalau ininya kita mulai dari 0, maka kita akan lihat ini ya, di sini ya. It should start from 0, the minimum. Ini. Agak susah ngelihatnya ya. Sometimes if we start from 0, we find it difficult to find out the best optimum KNN. That's why this is the overall matrix, and we need to zoom in to the values in certain axes to show which one's best from that range of value. Ya, misalnya gini. Nah, gini kan, misalnya 0.8. There you go. This is the zoom in version in the y-axis to show which one's best. It's easier for us when we go zoom in into this certain axis. Ya, kira-kira seperti itu untuk melakukan apa yang kita lakukan dengan sebuah algoritma KNN. Eksperimennya apa aja? Kira-kira seperti ini. This procedures is the best practice for us to find out which KNN works best, of the optimum KNN we need to use by finding out the hyperparameter that will produce a very good classification model. Oke, kira-kira